This is part 2 of the condensed version of everything you need to know about fractions. And in this portion we're going to talk about adding and subtracting fractions and mixed numbers. And we're going to look at this in a couple of different ways, since there were two different ways, one that was shown to you in your textbook and then one that I showed you on YouTube when we get to the mixed number sections. So for adding fractions, we need to find a lowest common denominator. And equivalent fractions. And if you remember back to the previous video, finding a lowest common denominator in equivalent fractions was covered in section 3.1. So doing that in this case, our common denominator, our lowest common denominator between 4 and 6 is going to be 12. And to find our equivalent fractions, we put the numerators back on top of the fractions and then multiply diagonally. So my new denominator for both fractions is going to be 12. And my new numerator for 3/4 is going to be 3 times 3, so it becomes 9/12. And my new denominator for 5/6 is 12, and the numerator would be 2 times 5, which is 10, giving us a final answer of 19/12. Now that fraction is improper, but since our original fractions didn't start as mixed numbers or improper fractions, we don't really have a hint as to whether or not they want this answer as an improper fraction or a mixed number, so either version is fine. So if you leave your final answer as 19/12, you are correct. If you want to change that into 1 7/12, that would be correct also. To do subtraction, we better finish writing the notes up here. So you find a lowest common denominator and equivalent fractions. Then you add the numerators. The denominators stay the same. And if it's possible to reduce, you should. But please remember that reducing and converting to a mixed number are not the same thing. So if you leave your final answer as 19/12, that's just fine. When we're doing subtraction with fractions, it's going to be exactly the same procedure as we did with addition, except that when we get to the add numerators step, we're going to subtract instead. So the rules for subtracting fractions are same as addition, except you're going to subtract numerators. So in this example, our denominators are 4 and 5, and when we look for a common factor between those, they don't have one, which is something we call relatively prime. So that means that our common denominator is just going to be the product we get when we multiply those two denominators together. Finding the equivalent fractions by placing their numerators back on top has us just multiplying the denominator of one fraction with the numerator of the other. So our equivalent fractions are both going to have denominators of 20. Whoops, and we're doing subtraction this time. And the numerator on the 3/4 is going to become a 15 over 20, And on the 2/5, 4 times 2 gives us an 8 over 20. Then we subtract our numerators. 15 minus 8 gives us 7. The denominator stays the same. And since 7 is a prime number that does not fit evenly into 20, we can't reduce this. And since the fraction is already proper, there's not a way to convert it to a mixed number. So we're done. Adding mixed numbers can be done one of two ways. You can either convert them to improper fractions and then follow the addition steps, just as we have up here, and then at the end convert back to mixed. So I'm going to show that example first. So in that case, this fraction would become 15/4 and this one 11/6. Our common denominator between 4 and 6, just as it was in this problem, is going to be 12. So these two fractions are going to become 12 in the denominators, with this numerator turning into a 45 and this one into a 22. Then we add those numerators together, giving us 67 over 12. And then our final step is to convert it back into a mixed number. So 12 fits into 67 5 times, since 12 times 5 is 60. And there are 7 left over to make our new numerator. So the final answer is 5 7/12. Your textbook shows an alternative way of doing this problem. It looks like this. So we're going to just copy the same problem again and try it the other way. 3 3/4 plus 1 5/6. In this example, they separate the whole numbers from the fractions and deal with the fractions separately and then recombine at the end. So we're still going to need a common denominator and equivalent fractions. And the common denominator is still 12. So this fraction becomes 9/12 and this fraction 10/12. Then you add the fractions and add the whole numbers. Adding the fractions gives us 19/12, and adding the whole numbers gives us 4. So this is where the problems usually arise, if we're going to have them. Writing 4 and 19/12, an improper fraction in a mixed number, is not the correct way to write this number, any more than if we were adding 19 and 25, we could write the 9 plus 5 with the 14 under there and the 3 here. We all know that that doesn't work, that you're required to write just the ones place and then carry the 10 over to the tens place. So the same thing is true when you're adding or when you're writing a mixed number. This has parts that enough parts to make a whole. Since 19/12 has 12/12 plus an additional 7/12 in it. So this 19/12, or this 12/12, needs to carry over and become a whole, much in the same way that the tens place needed to carry over, or when we added the ones place, the tens place needed to carry over into the tens column. This whole needs to carry over into the whole column making this answer 5 7/12, which is the same answer that we got doing this problem with the improper fraction method. Going back to the subtraction problem,